What are emotions? Are they something that happen to you, or are they bodily signals that we interpret? Does everyone show emotions in the same way? Are there particular markers of the face or body that always mean anger or sadness or joy? And what does this have to do with Charles Darwin, or the truth about facial expressions, or the movie Inside Out? Welcome to Inner Cosmos with me, David Eagleman. I'm a neuroscientist and an author at Stanford, and in these episodes, we sail deeply into our 3-pound universe to understand why and how our lives look the way they do. Today's episode is about emotions. Now, to set this up, let's think about emotion versus cognition. In the past half-century, neuroscience has been buzzing with discoveries about cognition, like how we perceive information, how we decide, that sort of thing. And this has all been enhanced by all the recent advances in artificial intelligence. So cognition is all about acquiring and using knowledge, recognizing patterns, storing and retrieving information, creating mental representations. But real neural networks, the ones living inside organisms, they operate in a very different context. Organisms are driven by needs and motives and pain and emotions. Without these driving forces, all the cognitive processes like learning and representing and taking action, these would lack purpose or direction. In other words, if nothing matters to an organism, there's no reason for it to learn or do anything. This is why understanding the brain requires us to include emotion, not just cognition. And this consideration has given rise to a field that we call affective neuroscience. In other words, the neuroscience of emotions, as a complement to the field of cognitive neuroscience. So what is different about these two fields? Well, at least traditionally, neuroscience thinks about cognition as representational and involving symbols and computation and degrees of accuracy in how well it reflects the world. But emotions, they don't fit that model. Take something like fear. It's not exactly about representation or symbols, and it doesn't have accuracy, but instead it varies in intensity. If emotions are like forces that rise and fall, or they mix or they remain pure, then cognition is maybe more like an encyclopedia, something structured and informational. Now, these metaphors are imperfect, but I'm just using these to tee up the divide between cognition and emotion in conventional thinking. Now, why has cognition received all the attention in the laboratory? Well, it's because we can build models or artificial neural networks to tackle cognitive tasks like chess and Go and math problems. It's a lot harder to set up clear experiments with emotions. And so these have traditionally received a lot less attention in the research world. But the thing to note is that emotions are much more ancient and at least appear to span the animal kingdom, while chess games do not. So emotions may be more fundamental in brain wiring. So how do emotions get studied? Let's start with Charles Darwin in his book, The Expression of the Emotion in Man and Animals, which he published in 1872. Darwin proposed that emotions are biological phenomena. They're deeply rooted in our evolutionary history. So he argued that our facial expressions of joy or sadness or anger or fear, they evolved to communicate essential information to ourselves and to others. So for example, it makes sense, he argued, for a person who is angry to stand tall and loom large and glare and tense their muscles. These actions prepare them for physical action, and these actions can also just serve as a visual threat of action. So Darwin proposed that emotions are survival tools passed down through the generations like well-oiled machinery. Although as a side note, he did mention that this appropriateness hypothesis can't be the whole story, since a lot of things didn't seem to fit, like a person who is sad, moping around and recreating conversations in his head and feeling drained. But we'll come back to this. So the general thing that Darwin emphasized is that certain emotions prepare our body to do the next thing. And he suggested this was universal across the animal kingdom. He said, look, expressions are essentially the same across mammalian species, and things can even look a little similar between mammals and reptiles and birds, like when the animal is afraid or angry or showing parental love. So, Darwin said, the core emotional operations relevant to behavior are evolutionarily highly conserved. So fast forward to the 20th century, and this research gained momentum with researchers like Paul Ekman. Ekman went around the world and he concluded that he could identify 6 basic emotions. There was happiness, sadness, anger, fear, disgust, and surprise. And these 6 emotions, he argued, are universal. Whether you are in New York or New Guinea, a smile means joy. And if you have a furrowed brow, that means worry, and so on. And this model of basic emotions that are universal, we see this framework everywhere around us. You've probably seen the Pixar movie Inside Out, which brought emotions to life. You had the characters of joy and sadness and anger and fear and disgust, and each one was personified as a little being running the control panel of a young girl's mind. And it was a great movie, and it captured the public imagination because it felt sort of true, right? These emotions seem like individual entities living inside us. They're always there. They're waiting to surface and take charge of the control panel. But what if I told you that everything you just heard about Darwin and Ekman and Inside Out is not really the full story about emotions? What if emotions aren't actually universal? What if they're not hardwired programs that move us like a marionette, but instead something we create and interpret? So the story of the neuroscience of emotions really started taking a turn with the work of one neuroscientist, Lisa Feldman Barrett. She's a professor of psychology at Northeastern University, and she wrote a book called How Emotions Are Made. Over the years, Barrett's work has really challenged everything we thought we knew about emotions. In her view, emotions aren't universal biological reflexes. They are constructed experiences shaped by our brains, by our past, and by our culture. So I called up Lisa to join us here today. And as we're about to see, her research flips the script. It suggests that your brain doesn't feel emotions as much as it predicts them. So that wave of joy or that stab of anger, it's not a reaction. It's your brain interpreting the signals of your body in the context of your situation and your life experience. So, Lisa, first I want to ask you what the classical view is of emotions, and then we're going to transition into how you see it and what your research has revealed. So let's start with the classical view. What does any student can learn in their psychology or neuroscience textbook about emotions?
Right. So you open up an intro textbook, or you could even open up a Harvard Business Review, or often even read the newspaper. And what you see is a view that humans are born with somewhere between 6 and 12, 15 circuits, one for each type of emotion: anger, sad, fear, disgust. The different scientists disagree on how many there are, but the idea is that you have these inborn emotions. Something happens in the world, triggers one of them, and you make a universal facial expression to express the state. Your body changes to express the physical state that is characteristic of that emotion, and you are likely to perform a specific behavior. So, for example, if your fear circuit is triggered, you'll make a wide-eyed gasping face. which is supposed to be universal. Everybody around the world is supposed to make that face when they're afraid and recognize that as an expression of fear. Your heart rate is supposed to race, and you're supposed to, be likely to flee or freeze or make some kind of characteristic movement. So that's a bit of a caricature, but not that much. That is actually the view that a lot of people still hold, actually.
And when you started graduate school, I assume you felt that was the right model as well. That's what you were taught. And so you started doing some research, and what happened there?
Yeah, so I wasn't even doing research on emotion, David. I started graduate school doing research on something else, but I had to measure emotion. And I was measuring emotion the way a lot of psychologists do, which is to ask people, how are you feeling? And what I did was instead of, analyzing what people said, I looked at the statistical structure of what they said. So instead of just averaging the ratings and saying, oh, this person is, reporting sadness or fear, I looked at the whole pattern of their reports, and I found people on average don't distinguish between feelings of sadness and fear and disgust. They basically group like all the negative emotion words together to report I feel terrible, and all the positive words to like I feel great. So I feel good, I feel bad, I feel comfortable, I feel uncomfortable. That's generally on average what it looked like. And I thought, well, everybody knows there are universal expressions for emotion, and everybody knows that there are these physical patterns, for different emotion categories. And eventually, everyone knows there are different circuits in the brain. So I should be able to objectively measure somebody's emotional state. And then I can compare that to their reports, because it turned out that when I looked a little closer, I could see that actually, on average, it looks like people aren't distinguishing, but some people distinguish pretty well, and other people, use anger, sad, and fearful to mean are synonyms. So I thought, well, I can just figure out like who's reporting accurately and who isn't. And I thought, not being an expert in emotion and also having the exuberance and unrealistic expectations of a graduate student, I thought, oh, this will just take me a couple of months. Like I'll figure it out, and then I'll be able to objectively, measure emotion, and I'll move on, and it'll be great. And that is not what happened.
So what did you find?
I went to the literature because, like probably you and almost everybody I know, we were all taught that each emotion category, that is anger, is a category of instances. So we were taught that there are certain categories that are universal and should have objective markers. So I started with the face, because everyone knows that Charles Darwin, when I say everyone, I mean, scientists know Charles Darwin wrote a book called The Expression of the Emotions in Man and Animals, and he claimed that there were these universal expressions. And so I went to the literature and I started to read, and what I discovered was that if you just read the introduction of papers and you read the discussion section of the papers, there are lots of claims about universal expressions. But if you actually look at the results and you sort of dig into the results, you don't see anything which looks like universal expressions. Actually, what you see is real variations. I'll give an example of a recent meta-analysis. So this is a statistical summary of, hundreds of studies, right? People on average scowl when they're angry. So scowling is the supposed universal expression of anger. People scowl when they're angry about 35% of the time. So that's more than chance, and therefore it will get you a good publication if you report that finding. But that means 65% of the time, people are doing something else that is meaningful with their face when they're angry. And other research suggests that about half the time when people scowl, they're not angry. They're feeling something else. And oftentimes it's not an emotion. And if you combine that with evidence from people who live in remote cultures, who have less access to Western values and norms for emotion, what you see is that there's nothing that looks like universality for anger or for any category that's ever been studied. So Scowling and anger is certainly one set of facial movements that people make in the West when they're angry, but it doesn't come anywhere close to having the reliability or specificity that we would need to see for a universal expression. And I'll just say that in my lab, we were very fortunate to be able to visit Tanzania and work with members of the Hadza hunter-gatherer culture. And we basically took 6 emotion categories that don't exist in English. They don't exist in Hadzane either. They have never been claimed to be universal. And then we just made up expressions for them. Like literally, we sat around a table, just made up expressions for them. We pre-tested them with American subjects to make sure that American subjects thought these were reasonable expressions of these emotions. We had to tell them what the emotion was, like there were one emotion category was giggle, which is the desire to squeeze a baby's cheeks. Like when you see a really cute baby and you just so there was that. And then we plopped it into the method that everybody uses when they do these cross-cultural studies. And the method produced evidence that 5 of the 6 of these categories were universal. So what I'm saying here is that there's a method that scientists are using that basically is teaching people what the right answers are. But the basic answer here is that for every claim of a universal marker or signature for emotion, if you just look closely and you start to poke a little bit at the research, it's like a house of cards. It sort of falls apart. And instead what you see is that variation is the norm, meaning you, David, probably do many things when you're angry. You probably sometimes feel unpleasant, and sometimes you might even feel pleasant. Your body probably does many things in anger. It's not random. It's structured by the situation. And that leads us to ask a whole set of different questions about emotion.
So when we think about an emotion like anger, it's not that there's one thing going on. It's not as though I have an anger circuit. So instead, there are lots of ways that I might express that based on the context that I'm in. Can you give an example of that?
Sure. Have you ever laughed in anger?
I don't remember if I've ever laughed in anger, but it's possible. What would be a situation where someone might do that?
I think people laugh in anger when they're insulted in some way, and they cry in anger. I've certainly cried in anger. People sit stoically and, plot the demise of their enemy in anger. They make no expression whatsoever. I mean, I'm sure you've been in a faculty meeting where you've done that. I certainly have had my moments. I think if you look to the literature, what you see is that people do all kinds of things in anger. Heart rate can go up, it can go down. Blood pressure can go up, it can go down. It can stay the same. There's not a single pattern. And when it comes to the brain, there is no single circuit for anger or sadness or fear. It's not even like there are multiple circuits. What you see in the brain is that there are ingredients or components that work together. So anger is a whole brain state. It's not a single circuit. In fact, any research that claims to have identified a distinct circuit for an emotion is usually equating an emotion with a specific action. So when you read research that talks about the fear circuit, they mean the circuit in animals when the animal freezes. Really careful research shows, for example, if you place a rat in a testing box and you expose the rat to a tone and then a foot shock, eventually the rat will come to freeze when it hears the tone. This is what scientists refer to as learned fear. So they're equating a freezing behavior to fear, and then they look for the circuit for that freezing behavior, and then they call it the circuit for fear. The really interesting thing is that recent research, for example, will train a rat in the way that we just discussed, mark the neurons that increase their firing, and then reactivate those neurons optogenetically with light. And then they look throughout the entire brain. Well, what else is being, so not just looking at the the circuit, like let's say the little subcortical circuit that they might be interested in, but they look at through the whole brain. And what you see is that there's actually a whole brain ensemble of neurons which are increasing their firing. Two interesting things to me in this body of work. Oftentimes scientists think the fear circuit is in neurons in this little area called the amygdala, which is deep inside the temporal lobe of a vertebrate brain. If you reactivate the neurons in the amygdala and you bring up this whole brain-wide ensemble of neurons, but you interfere with the firing of the other neurons, including in the cerebral cortex, you don't get freezing behavior. So it's the whole ensemble that's producing that behavior, not just the neurons in the amygdala. But even more so, what's interesting is that if you put the animal in a different box, one that doesn't look very much like the box in which it learned to freeze, those neurons that you've activated are part of a different ensemble and no freezing behavior happens. So you've got this situation where the neurons in question are clearly doing something, but whatever they're doing, they're working in a larger group. So their psychological meaning is related or relational or dependent on that group. And it's very context sensitive, and it's just explaining freezing behavior. It's not explaining all the other things that animals do in fear. This is just one thing they do in a particular kind of context.
So when you look at a movie like Inside Out, and you've got these different emotions and they hit a button and cause some behavior, what your research has shown for a few decades now is that it doesn't seem to be the right explanation for emotion. Why do you think that view is so popular? And more importantly, what is your theory about constructed emotions? Explain that to us.
Yeah. Well, first, can I just say about Inside Out? I have to say, I've seen both movies and I love them. I think they're totally fun. They have really, really clever metaphors that I love. And I think in the second movie, I particularly loved Ennui. I just loved that character. But what I'll say is that I also really like Roadrunner and Wile E. Coyote cartoons, but I don't think that I can learn physics from it. So the idea that you could learn neuroscience, the neuroscience of emotion from a cartoon, and particularly from Pixar that can put emotions into cockroaches and cars, and, they're so clever, right? I think there's nothing wrong with what Pixar did. But the marketing is pretty problematic. And I also want to point out that you just watch any single one of those characters, anger or embarrassment, any of them, and they show they have a range of emotions. They display a range of expressions. If they only ever did their one thing, it would be a really boring movie.
Yeah. So tell us about your theory of constructed emotion and what the right way is to think about this.
Well, I don't know if it's the right way, but it's certainly a different way, and I think a way that's more justified by the available evidence. And so I'll say that for a long time, I didn't have a theory. I just was trying to learn. We're faced with a paradox, really, and that is that there's no single biological marker or pattern of biological markers that, like no biomarkers for any category of emotion. Yet, when I'm angry, I feel angry, and I don't feel sad or happy, or I have an immediate reaction, and I don't think about why I'm having it or which one I'm having, and pretty much people, that's their experience. They feel like emotions happen to them. It feels like something's being triggered. So you've got these subjective experiences of certainty. And then on the other hand, you've got this biological question of like, well, there are no markers anywhere. Plus what you have is tremendous variation across cultures, just even in the categories that exist. So not all the categories that we think of as basic in English actually exist in other languages. And there are many other categories that are basic for other languages that don't exist in our language. So how do you account for all of this in one theory? This was a puzzle to me for a really long time. So what I did is I started to study brain evolution So how do brains evolve, and how are they structured, and how do they work? So instead of doing what most scientists do, is they say, okay, well, I'm really interested in anger or fear or sadness, so I'm going to go looking for the physical basis of those emotions in the brain or in the body. I started with the brain and body and said, okay, well, to the best of our knowledge, how did a brain like ours evolve? How does it work? How is it structured? What's its anatomy? And then how is it, communicating with the body? And then given that we have that kind of biology, how could it be creating the instances or the events that we experience as emotion? And I came up with a really different set of hypotheses that required a really different way of doing science. And it's a little more complicated than you've got a circuit in your brain that you were born with that triggers and then produces an emotion, prototypic emotion. And the theory goes something like this. Your brain's most important job is regulating your body. It's not to think or feel or see even. It's to regulate the systems of your body in a metabolically efficient way. That's actually the basis of everything your brain does, and anything you see or feel or hear or think is in the service of that regulation. So that's the first piece. Your brain, as part of this regulation, it's always receiving signals from the body and signals from the world. So every experience you have, every action you take is some combination of what's inside your brain and what's outside your brain coming to the sensory surfaces of your body. So your brain's always regulating your body. Your body's always sending sensory signals back to your brain to report on the sensory consequences of those movements inside your body, your heart beating, your lungs expanding, whatever. But also you're always receiving sensory signals from the surfaces, sensory surfaces that we think of as exteroceptive signals. The interesting thing is that these signals, from the brain's perspective, are ambiguous because the brain is trapped in a dark, silent box called your skull. And these signals are the outcomes of some set of changes in the body and in the world that the brain has no access to, right? So like a loud bang could be a door slamming, a car backfiring, or a gunshot. What your brain will do to keep itself alive and well is very different in those circumstances. So how does it know? And the answer is it has to guess. This is what philosophers call an inverse problem. And, where you receive the outcome, but you don't know the cause. You have to guess at the cause. And what does the brain use to guess? It uses past experience. It's remembering. And you don't experience yourself remembering, but basically your brain is remembering a bunch of instances from the past that are similar to the present. A bunch of things which are similar is called a category. So your brain's basically using the past to construct categories in the moment that will allow it to prepare action. The interesting thing is that research suggests the brain is functioning predictively, which means the guess starts before the sensory signals arrive. So if we were to stop time right now, your brain is modeling what it believes to be the sensory state of your body and the sensory conditions of the world. And based on that, it's reinstating a bunch of partial representations, a category that's similar to the present as a way of preparing the regulation of the body, anticipating the needs of the body and preparing to meet those needs before they arise so that movements can occur, like eye movements or muscle movements. And the consequences of those movements are the predicted sensory inputs that are arriving from the sensory surfaces. And so the brain is comparing those, and the result is your experience. So what's interesting about this perspective is a couple of things. One is that it's not like you see something and then react to it and then move. Perception is a consequence of movement preparation, not the other way around. The brain is functioning predictively, even though it creates experiences of the world as if it's reacting to the world. So there's a real puzzle here, which is, why would a brain function predictively but create experiences of reactions? Nobody knows the answer to that question. And the way that emotions are constructed are the way that every psychological feature is constructed. There's no specific set of mechanisms to emotion that would be different from cognition or perception or attention or what have you.
Do you think of emotion as being sort of a wider angle lens on a situation? So when I think about cognition, it feels like, okay, what's the next chess move I'm going to make? And I'm really focused on something. Emotion sometimes feels to me like, give me the wider view of what's happening here. Is this a good situation? Is this a bad situation?
I think that things like cognition and emotion and attention and perception are features of a brain state. I think if they're features that happen to be very salient, then we call the event a thought or a memory or an emotion or a perception. But I think about the brain holistically as a dynamical system, a system of neurons and other bits and bobs that moves from state to state to state. Or you could say traverses of state space, like it always is in a state and the nature of the state changes. So I think about emotions as, for example, your brain is always regulating your body or you'd be dead. So it's always regulating the body. Body's always sending signals back to the brain. It's very infrequently that you will experience those signals as your heart pounding or your lungs expanding. You never feel, your liver excreting chemicals or hormones. Like you just don't experience those things. The brain's tracking it, but it's not making that information available to itself. Instead, what we feel is affect. We feel pleasant. We feel unpleasant. We feel calm. We feel worked up. Those are really simple feelings. That are with us all the time in every waking moment of life. So they're really properties of consciousness. When they get really intense, those are the moments that we experience them as emotions, but they're always there, even in moments of cognition or perception, for example. I also want to say that there are many cultures in the world that don't distinguish cognition from emotion. Like that's not how people in certain cultures experience themselves in the world. They don't make that distinction. That's a very Western distinction. And I think we have to have a theory of brain function that accommodates everybody's experience, not just certain people's experience, because we happen to be the ones with the money and who are in control of the journals,
That's interesting. I mean, what's your experience? I feel like when I'm concentrating on something very specific, like the chess move, that feels different to me than if I'm just feeling generally happy or sad or something.
It does. But so does, in one instance of happiness can feel entirely different than another feeling of happiness. So my point, the question we would ask, is there something similar to the brain state for lots of different instances of happiness? So we took all the instances where you were deciding on a chess move. Would those brain states look more similar to each other than if we looked at all the brain states you had for chess moves and happiness? And the answer is not so far. There's just structured variation. So when you're happy, that's not the same state for you all the time. People do lots of things when they are happy. They express in different ways. They have the mental features of their experience can change. Their physical state can be different. It's not random. It's structured by the situation that they're in, including the physical condition of their body and their metabolic state. And there's nothing objectively more similar about those instances of happiness than is objectively different between happiness and instances of planning a chess move. And the interesting question there is why it feels that way to us. It's a question of consciousness. It's not a question of objective brain function.
What is your take on that answer? Why it feels different? Why we have a distinction, let's say in the West, between, let's say, cognition on one end of the spectrum and emotion on another end of the spectrum?
I don't know exactly why we have categories for cognition and emotion that are so entrenched, but I will say that they derived not out of a theory of brain function, but of a theory of morality in ancient Greece. So that's how old they are. That, you have an inner beast of emotions and instincts, and that inner beast has to be kept in check by cognition by rationality. And if you keep that inner beast in check, you're a moral person and you're a healthy person. And if you don't, then you're either immoral or you're immature or you're mentally ill. This idea of that your mind is a battleground between cognition and emotion is a very old idea. You can see it in Plato's writings, and it's embedded in the law. It's embedded in economics. It's just a pervasive idea that has no evidence to support it in brain evolution or brain function.
I have a question, though. I'm not sure I think that's the distinction that I feel about, keeping the beast in check. It's more like if I'm planning my next, let's say, chess move, then I'm thinking about steps. I can do it in a very clear, rational way. But if I'm at a party and I'm thinking, wow, I'm having a great time at this party, or, oh, I don't really like this party so much or something. I just, I have some feeling about it. I might not be able to specify the details of why, but nonetheless, I'm awash in some feeling, some emotion about this. And that's the distinction that I intuitively feel. I'm curious if you see that as a meaningful spectrum.
So I would say it's a meaningful question about consciousness. It's not a meaningful question about brain structure or brain function, in the sense that our intuitions, our experiences of the world in general are very bad explanatory guides for how the world works. And this is also true when brains are trying to explain themselves, right? So I would say, there are probably times when you're planning a chess move that you're really frustrated. And there are probably times when you're really happy that you're thinking about strategically, how can I meet that person? Or how could I get away from this person? So I think that this is a question of which mental features are in the focus of attention and which ones are in the background. Like right now, for example, if you are sitting, are you sitting or standing?
I am. I'm sitting.
Okay, so right now, for example, you're probably not concentrating on the press of the chair against the back of your thighs until now that I just said it. You probably are thinking about that for a minute, right? So there are features of experience that are available to you that are not in the forefront of your experience, but you can move them in and out pretty easily. And that's really how I think about it. So, for example, the next time that you find yourself being really, really hungry, take a moment and focus your attention on your stomach. Are you hungry or are you tired? Because if you're tired and you need some energy, your first reaction will be to eat, because you have a history of learning that energy comes from eat. Like the feeling of having more energy happens after you eat. But a lot of the time when we're tired, we should be drinking water, not eating, because dehydration is fatigue. Research shows, for example, that when you drink a glass of water, your thirst is immediately quenched. But actually, it takes 20 minutes for the water to make its way into your bloodstream, to change the osmolarity of your blood, to get to the brain, to tell the brain that now you are hydrated. So the brain is constructing experience, it's predicting what the sensory consequences of actions will be, and you start to experience the consequences well before the actual input arrives to the brain to confirm those. So I wouldn't go looking for distinctions between cognition and emotion, because people have looked for those distinctions for years and years and years. And the one thing that we've learned from all of that research is that it's the wrong question to be asking. Instead, it's a question about experience and the way the brain is constructing experience, lived experience. And that's where we should be asking those neuroscience-based questions, I think.
Could the concept of constructed emotions tell us something about AI and the future of machines being able to simulate or understand our emotions?
Everything from evolutionary biology and neuroscience tells us that the core of brain function is rooted in the regulation of the body. There are metabolic constraints and selection pressures that give us the kind of mind we have. And that means that there's this sort of imperative that is largely hidden, but that scaffolds everything we see and feel and think. AI doesn't have that. I'm not saying an AI has to have a body. I'm saying it has to have a set of really complicated systems that it has to regulate, because that's actually at the basis of our human minds, actually of any mind, of any living creature. I'm not reducing everything to metabolism or bodily regulation, but it's a hugely important piece that we all overlook because we're not aware of it. Right now, you and I and every listener has a whole drama going on inside each of us that I hope we're largely unaware of, because whenever we become slightly aware of that drama, we're usually really uncomfortable and we can't pay attention to anything outside in the world. So I think that that's a huge piece of what it means to have a human mind. Evolutionarily and structurally and functionally at the core of your brain, it's predictive regulation of the body. So exactly the same brain regions, exactly the same neurons in certain cases that are regulating the body are also implicated in attention or memory or emotion or vision, right? So the hippocampus, people think of this structure as being for memory or for spatial navigation, but it has more endocrine receptors than any other part of the brain except the hypothalamus. It is clearly a hub for the predictive regulation of the body, but that's not how people think of it, because they're more concerned with understanding the other functions which result from that regulation, like memory or spatial navigation.
How does your theory of emotion change the way that we think about mental health treatments like depression or anxiety?
The way the brain regulates metabolism is that it's running a budget for the body. And I would say depression is a bankrupt body budget. The brain believes that there's a metabolic problem somewhere in the body. And so it's reducing energy output. And the way the brain reduces energy output is by reducing movement, reducing sensitivity to the outside world, and inducing feelings of fatigue so that you won't move very much. So you get context insensitivity, which is a major symptom of depression. You also get fatigue and motor retardation. So people don't move as much, they move more slowly. So the brain is attempting to reduce energy output. And the clincher for me is that a couple of things. One is that there's a test, a biological test for depression that involves looking at cortisol levels, which is a chemical that people call a stress hormone. Cortisol it regulates glucose metabolism. So if you have problems with glucose metabolism, then you will very likely have depressed mood. And serotonin actually evolved as a metabolic regulator. Serotonin reuptake inhibitors are not happiest drugs. They're drugs that influence metabolism. And whatever affective consequences they have are because they are regulating metabolism.
So Lisa, tell us some practical takeaways from your research that listeners can think about when they're thinking about how to manage their own emotions.
The first thing I would be doing is asking yourself, like when you feel like crap, feeling like crap doesn't mean that something's wrong. It could mean that you're just doing something really hard, or that you didn't get a good night's sleep, or that you're dehydrated in some way. So it doesn't necessarily mean something is wrong with your life or something is wrong with you. In our culture, we believe that thoughts cause feelings, but actually, if you look at the predictive functioning of the brain, it suggests that the signals which give rise to feelings also give rise to thoughts. So if you feel like shit, you're probably it's going to feel to you like you're a horrible person and that the world is terrible, or you need to divorce your spouse, or your kids are, misbehaving or whatever. We have a tendency to see the world through affect-colored glasses because of how we're wired. So the first thing that I do when I feel like the world is ending, because lots of bad things are happening, the first thing I ask myself is, did I get enough sleep last night? Have I had enough water to drink? Is it better for me to have a bath and go to bed and get up tomorrow and things will look different? Even in the worst of circumstances, that's always a good strategy.
That was Lisa Feldman Barrett, professor at Northeastern University and one of the world's experts on emotion. And I'll just mention she's one of the top 1% of the most cited psychologists in the world. So, to summarize what we saw today, for decades, there was a research avalanche suggesting that emotions are the same across all people. And we had Darwin's universal expressions of emotions. And we had Paul Ekman's suggestion that there were a handful of basic emotions. And we had Pixar's Inside Out. There seemed to be a clear map of the emotional landscape that was coming into focus. But as we saw, Barrett and her lab came to very different conclusions. She became skeptical that there was universality of emotional expression, like what she mentioned about the assumption that people scowl when they're angry. But it turns out when you study this carefully, 65% of the time people do something else when they're angry. They don't scowl. And also, when you do see a scowl, it's only a 50% chance that this has to do with anger versus something else. So, Barrett argues that emotions are not universal reflexes. They are instead constructed. They're shaped by the brain's predictive power and our cultural context and our individual experiences. In other words, her framework highlights the role of the brain's internal model in interpreting sensations from the body, what's called interoception, and assigning meaning to those sensations, creating what we label as emotions. It's a paradigm shift that invites us to reconsider not only what emotions are, but what they mean. If emotions are constructed, then they're not simply happening to us, they're happening with us. So take a minute to think about some moments in your life when you felt something deeply, love or rage or despair or hope. Barrett's framework suggests that in those moments, your brain was hard at work pulling together past experiences and bodily sensations and environmental clues to create the emotion that you felt. It wasn't a reflex, it was a narrative. And if emotions are readouts from the body, then maybe we can get just slightly more agency over them. Not in the sense of controlling our feelings, they're too complex for that, but in shaping how we interpret and respond to them. Take something like anger. In the classical view, anger is a red-hot reaction. It's the little guy with fire coming out of his head. It's beyond our control. But if anger is constructed, maybe we can probe it a bit. What is my body telling me? Why does this situation feel threatening? How can I reframe this moment? Because emotions appear to be not something we simply have, but something we make, not pre-programmed reactions, but dynamic constructions shaped by our past and our brain's predictions of the future. Understanding this can change, potentially, how we see ourselves and others. Our moments of joy and fear and love and anger, they're not fixed, but they're flexible. They're a reflection of the stories that our brains create. And perhaps in knowing this, we can maybe learn to shape those stories a little better, not as readers, but as authors. Go to eagleman.com/podcast for more information and to find further reading. Send me an email at podcast@eagleman.com with questions or discussion. And check out and subscribe to Inner Cosmos on YouTube for videos of each episode and to leave comments. Until next time, I'm David Eagleman, and this is Inner Cosmos.